How's it going, everybody, and welcome back to our Cisco Enterprise series. In this video, we're going to knock out all of our spanning tree topics in one video. Hopefully it doesn't take us too long. I will be skipping over a couple of topics that I've already discussed. I will be doing we'll be taking a look at, we have 4 VLANs, the 1315, 1316, 1318, and 1319. I will be configuring switch 1 to be the root bridge for all odd numbered VLANs, and switch 2 to be the root bridge for all even numbered VLANs. And we'll go from there with that. Across the board for all of our different switch modes and things like that. We've already taken a look at switch priority, the port priority, and the path cost. So I'll be monkeying with the timers, but I'll still show you guys how to, on a per mode basis, how to change things around on switch 1 and switch 2. I'll show you guys how to deploy port fast and how that comes into play. A couple different variations for that. BPDU guard, BPDU filter, and then we'll take a look at root guard and loop guard to wrap things up. So with that being said, let's go ahead and dive into our topics and get that process started. I'm going to take this off screen so I can keep my list of topics to cover available to you guys. Pull this guy up here, and let me put that guy right there. Okay, so first and foremost, on switch 1, before I do that though, let me talk briefly about something else. So let me talk a little bit about the concept of primary and secondary when it comes to spanning tree. So let me go in here real quick, and we're gonna, I glazed over it before, but if you type in spanning tree VLAN, and you say the VLAN number, so like VLAN 1, you have a couple of different things that you can modify when it comes down to the priority, the root, the max age, the forward time, the hello time, stuff like that. So if you type in the priority command, you must know the actual priority value that you want to adjust to when you make the configuration change. So you start up at 32768, and so if you want to adjust for this particular switch to become the root bridge for that VLAN, you need to either figure out how many increments of 4096 you want to enter, whether it's 1, 2, 3, 4, etc. Or my personal favorite is the root command. Configure switches root, and then you can do a primary, secondary. So if you use the primary command, so I type in primary, and I type in do show run, and I scroll down here a little bit, what's going to end up happening is it's going to use spanning tree VLAN 1 priority 24576. What this is doing, the primary command is going to deduct 2 increments of 4096, so 8192 from 32768. So if I do that, remember, the lower the priority value is, the more preferential your chances are of becoming the root bridge for that particular VLAN. Now in switch 2, I'm going to go to global configure and type in spanning tree VLAN 1 root secondary. Do show run. Come down here to here, where it says spanning tree VLAN 1 priority 28672. So what's actually happening is when you use the primary command, you're deducting 8192 from 32768. 32768. Yeah, 32768. Where if you type in the secondary command, you're removing 4096 from 32768. So you're deducting 2 increments of 4096 if you use the root, a root primary, and 1 increment of 4096 if you use the secondary command, which would make, type in do show span, would make switch 1 the root bridge for this particular VLAN. If I look at this guy here and I type in do show span, we're going to see this bridge is the root. right? And we know that because the priority value is 24,577. So because of that, that is the key piece that I want you guys to remember when it comes to how this configuration comes into play. I prefer using the root primary, root secondary command because it literally gives you the primary secondary thing where you don't actually have to type in the priority value. So it gives you what you want. And I have literally never memorized this number. I don't ever need to. I mean, I could figure it out. I could do some quick math and figure it out. But the bottom line here is that I want to be able to just make a quick change at the switch level and know that for a fact that the configuration is going to go this particular direction for that. So that's essentially the first thing that I wanted to show you. So what I'm going to do is I'm going to walk you guys through the config on switch 1 for all the odd numbered VLANs. So I'm going to type in here spanning tree VLAN 1 1315 and 1319. It is going to be root primary. Okay. Now if I take that same command, and then I need to type in spanning tree VLAN, and it's going to be 1316, 1318, root secondary. Okay. Now if I go over to switch 2 and do the exact same thing, spanning tree VLAN 1 1315, 1319, root secondary, and then spanning tree VLAN 1316, 1318, root primary. Now if I go to switch 1 and I do show span for VLAN 1316, we're going to see that the bridge, the root bridge, is switch 2. And we know that the root port is cost of 1, the first port, and that is port 1 is going to be gig 0/0. In this particular case, that's how this would come into play. So we know that that one is squared away. So that's how you would achieve that particular goal. So that's how you would take a look at that. Pretty straightforward. Same thing with this guy here. If I do show span for VLAN 1, we can see that switch 2, the root port here is, you notice it's port 2, which is the second port, and you know that by the number here. If you're curious on what that is, always remember the 1 correlates to this guy right here. So this number right here, the dot 1, and this indicate the very first port on the switch. So over here we've got it flipped because here it's a little bit different. So because of the way we've got it configured for 1316, then if I looked at 1318, it would give me the exact same thing. But if I looked at VLAN 1, you notice how for this guy we are the root. But if I looked at anything else, if I wanted to make an adjustment, I'd have to go in there and make an adjustment. But like if you notice here, before I changed the priority number to 32.2, when there's no other influence than the 32 number being lower than everybody else, made at the time, let me scroll back up here. I have to probably go back up here a little bit to when I was talking about how well, that's not going to show me the way I wanted it to. We could see that this was a root. Okay, never mind. I take that back. So the 32 that's configured on switch 1 port gig 0/1 influenced how gig 0/1 on switch 2 worked, because they're passing that information back and forth. So that is why gig 0/1 is the root port and not gig 0/0. Because by default, the first port is always there. So if I was to do show run, let me go over here to switch 1 and go to do show run interface gig 0/1 and type in no, or actually let's go interface gig 0/1 and type in no spanning tree port priority 32. Paste that in and remove it. And then go over to switch 2. If I do this, it should, might take it some time, but there might be a reconvergence. Yep, it's reconverging because spanning tree is recalculating and it's realizing that gig 0/1 should be the, or gig 0/0, excuse me. So this interface right here should be the root port. The lowest interface on the switch will always attempt to become, because that's how the spanning tree algorithm is written for it to do its job. So in this particular case here, I removed that command and therefore it's trying to flip back over. And now we're learning. And you notice it's taking some time. It doesn't go into it very, very quickly. But now it's in forwarding. And now gig 0/1 is back in the blocking state as an alternate port. So we have that in place. So now that we've covered that piece and we're good to go there, so we've been able to manipulate that piece and everybody's happy. The next thing we're going to go take a look at is going to be, we took a look at tuning the path cost on switch 4, I believe. Yep, so we were able to adjust the path cost so that gig 0/1 would be the root port. So it would go, actually I chose it to go the suboptimal path. So normally you would want the traffic to go from switch 4 via gig 0/0 to gig 0/3 on switch 1. Right, that's normally, this would be the optimal path. You wouldn't want the traffic going gig 0/1 to gig 0/3 on switch 2, and then from switch 2 via gig 0/0 to gig 0/0 on switch 1. This path right here would be suboptimal. Let me actually draw that out real quick. This would be orange. This would be the suboptimal path. This guy here would be the optimal path. So you'd want the green path, not the orange path. So we can affect that by going down to the interface level and removing the spanning tree port cost. So let's do that. So we're going to go on here. We're going to do show run interface gig 0/0. We can see the spanning tree cost is 20. So interface gig 0/0, no spanning tree cost of 20. That's going to bring it back down to its defaults. Do show span. So now for VLAN 1315, so now we can see that gig 0/0 is now listening. So now we are back to where the optimal path is gig 0/0 because it's got the lower, it's the lowest interface, so therefore it's the root port. The root port should always be the lowest interface unless you change something else. So one question that I get when I talk about this is, okay, great, that's cool that you could make that change, but why would you? Why would you want to go in there and either change the port priority on the upstream switch to change which downstream switch port becomes the root port, and why would you want to change the spanning tree path cost, or cost to change the path from one switch to another? And the answer to this is very, very simple. Have you ever had to deal with a maintenance window and you can't take a switch down? It's always got to stay up. So you can go through and make an adjustment to say, okay, I want to redirect all the traffic away from this particular switch for a period of time. So that is going to be how you would manipulate that, is you would either go upstream of that switch and adjust the port priority so that the downstream connections to that switch choose to different interface, or you can switch around it, assuming that you have the ability of switching around it and you're not like this environment right down here where you're literally just only got one link between the two. In the event that you are for example, switch 2 needed to go through a code upgrade, for example. Well, you could change the, let's say for kicks and giggles that switch 2 was the root bridge for a period of time, and you wanted it to be switch 1, and you wanted the root port to be over here. Well, you could change the root bridge to switch 1, and then that would force it to go gig 0/0. But let's say you don't want to do that. Let's say you just want it to redirect and go via gig 0/0. You could change the port priority on gig 2 to be something higher, and then gig 0/0 would take this path because this one would be less preferred. So you're trying to use the logic of spanning tree to affect the underlying forwarding capability of how spanning tree would determine what the best path in the network would be. It is no different than trying to leverage a routing protocol like OSPF or EIGRP or what have you to say, I want to take myself out of the decision-making process for routing. Do not route towards me. In OSPF, it's the max metric router LSA, saying I'm going to advertise the maximum metric for all of my LSAs, like say advertisements, so you don't choose me as a best path in your SPF check, your shortest path first check. So the idea is to switch around the environment if you have the ability to do so. Sometimes you don't. I'll be honest with you. There are times when you don't have the luxury of doing that. You have to go through and do things a certain way or else they won't work. So there are environments that I've worked in where they've told me, Rob, point blank, we cannot have downtime. We cannot have an outage. Okay, well, whenever I hear a customer say we can't have an outage, regardless of a misconfiguration on your part where you either don't think something completely through or you don't, something happens, something goes sideways, what have you, whether it's your fault or not, we cannot have an outage. So therefore you need to take it a step further and do your due diligence as the engineer to say, okay, how can I do this? You may not know the answer off the top of your head. I don't always know the answer, although I'd say probably a good portion of the time I have a theory, like, well, we might be able to do this. Let me go do some research on that, because at the end of the day, one thing that we don't do, I don't care how many CCIEs you have or how many years of experience, one thing that you don't ever do is you don't have every little nerd knob, and I'm going to come in here, you're not going to have all the little nerd knobs here memorized so that you never ever ever need to go reference the documentation. One key thing that every engineer that I know that has been doing this type of work for any length of time can tell you is that their Google foo and their researching abilities are really, really good because of the fact that they do their due diligence to make sure that if there is a problem, they can identify the problem and then rectify it. Simple as that. So if somebody came to me and told me that we can't have any downtime, I'd be like, okay, well, let me see if I can't figure something out. Then I would go in documentation, I'd pull up a lab, I'd test something out, and be like, and I'd come back like a day or two later and be like, okay, here's what I'm suggesting we do. If we can, the idea is to do this, whether it is do this or do that, and then this is what I was able to test in a lab. Sometimes I'm not able to recreate the problem. There are times when you're not able to recreate the issue, and in the event that you are not able to recreate the issue, or you're able to come up with a scenario where we can't have an outage, there are often times where you'll be able to reach out to vendor support. So I have done very, very basic deployments of a particular capability. I won't get into the specifics, where the customer always had vendor support on the phone, on the call with us. They would open up they'd call Cisco or Palo Alto or whatever vendor. They'd open up a case with that vendor's support, TAC or what have you, and then they would ask for a proactive interaction, meaning they would have a TAC engineer scheduled or dispatched to be on that call at a certain time. So I go into that level of detail because whether or not I've done my job or not, I've had simple code upgrades where I've had TAC on the call. I've had when I've done BFD deployments with BGP, which we'll talk about when we get into BGP right here. So I've been on a number of calls where I've had TAC on the line with me and I'm troubleshooting the problem, or I'd say most of the time I know how to fix the problem before we get there. Um, it all goes into how you handle the situation. So if you hear the term "we can't have an outage," well, you do your best to have not to have one, but sometimes it's 100% outside of your control. Things just don't always go the way you need them to, and honestly, any customer says we cannot have an outage, um, when I hear that, I often will be like, okay, time out. What do we got to do? How far up into the business do we have to go so that that line is never said to me again? Because I'm not going to take full responsibility for something that I might not have any control over. You know, I'll give you a great example. I forget how many years ago it was now, but I was working for a Cisco partner as a third-party consultant, and the project that was handed to me by resource management or whoever it was to do a very simple code upgrade on a Cisco switch. I think it was a 3750 gig switch or 24 port switch. I do remember that. And the task was simply to upgrade the code. It was a minor, it was like a 12.1 to like 12.2. There was some new thing or capability, or they wanted to do a code upgrade. It was like a standardization, something along those lines. I don't remember the specifics because it was so long ago. But so I ended up taking and that switch does not have a USB port on the back of it. So you can't just plug a USB port into it. We literally had to copy the code to the flash on the switch and then execute the command on the switch. So it took a while to upload the code, not forever, but there was a period of time where we had to do that. We did that before I was on site, so we weren't waiting for an upload to happen. And then once this code was there and the maintenance window started, like 8 o'clock at night or whatever it was, well, I did a write mem and I did a reload, and I set the boot statement to the new version of code, and I was consoled into the switch to watch everything come online like I normally would, and within 10 minutes of me doing that, the switch was not coming back online. And I'm like, okay, and so I've got a manager, I've got a director, they're all looking at my screen, looking at the switch, and they're like, what's going on? I'm like, if I had a guess, I'd say the switch just bricked itself. I mean, that's my best guess. So I was on my phone, because that's what you're doing. You're on your phone Googling things to try to figure out the problem. And right away, before we weren't even 15 minutes into this switch reload, the switch was not coming back online. At that particular time, 10, maybe 15 minutes, the switch should have been fully back online and working on the new version of code. Because we weren't at the point where we were doing like micro code upgrades inside of ROM for the read-only, or for the post process. It wasn't that type of an upgrade. It was still, we were before 15 code, 12 code. I don't remember ever having to deal with a microcode upgrade. So I looked at the customer engineer, and I said, we need to get on the phone with TAC and get them involved because we might have to do an RMA. And somebody there, I don't know who this person was, got very, very irritated at the fact that, well, we should have thought about that ahead of time. And I'm like, well, yeah, we probably could have had them on the phone or, on a WebEx, but, it's like nobody had thought about that. So whoever this person was, they got very agitated very, very quickly. And I said, I'm sorry, man. I was like, I didn't think we were going to run into that problem. And next thing you know, fortunately they did have support on that switch, because I've been in situations where I've said, well, let's call TAC. Like, we don't have support on the switch. I'm like, oh, well, there you go. Like, well, let's hop on eBay and see if we can't get something here within the next couple days. Or can we run these, cables to another switch and, get you guys online, quicker, quick, fast, and in a hurry. I've seen all kinds of stuff happen. So you do your best, but sometimes you run into those situations. I know it's kind of a long story, but stuff like that does pop up. So now that we've gotten that taken care of, we've done the switch priority, so we have all the switches figuring out where they need to go. So let's just actually, I should really be focusing on that. Let's go to switch 3 and do a show spanning tree. So VLAN 1 is choosing itself for whatever reason. But VLAN 1315 is choosing switch 1. 1316 is choosing switch 2. 1318 is choosing switch 2. And we don't even have 1319 here. So spanning tree is doing its job, and everything else is looking good from there. We'll do a quick check on switch 4. We'll do a show spanning tree. Switch 1, or this guy's still saying it's the root for VLAN 1, which is weird. So we have 1318, 1316 are both pointing towards switch 2. 1315 is pointing towards switch 1, which is exactly what we expected to do. Okay, so the switch priorities have been set, and we have our, we're distributing the load for spanning tree between both switches, which is exactly what I want to have happen. We've taken a look at the switch priority, the port priority, the tuning port, path costs. Next thing I'm going to do is I'm going to modify the timers. So we're going to say spanning tree VLAN, let's say 1315. I'm going to say we have some different timers. So do show spanning tree for VLAN 1315. Well, we can see that we have a hello timer of 2 seconds, a forward delay of 15 seconds. So this is going to be the listening and learning. And then we have a max age timer of 20 seconds. So there's going to be hello sent every 2 seconds. You're going to have 2 intervals, listening and learning, 15 seconds each. So that's 30 seconds there. And the max age is 20 seconds. So what I'm going to do is I'm going to say spanning tree VLAN 1315. The hello time is going to be, let's say, 1 second. Then the max age is going to be 6. And then the forward time is going to be, let's say, 4. Okay, so now that I've done that, I'm going to type in do show VLAN 1315. VLAN 13. Oh, sorry, do show span 1315. Do show span, VLAN 1315. Okay, so we have 1 second hello, max age is 6, forward delay is that. So what would end up happening is this switch is sending hello, so the CPU on this switch just increased slightly because now you're sending more hellos faster. And if there was a reconvergence, the max age would be 6, so we'd have a total of 4, 8, 6, so we'd be at 14 seconds is the quickest we'd be able to tune this to do the job. So that would be the timers. So I'm not going to test this because you got to remember that everything is sitting on top of one CPU. Well, it's technically a dual core processor, or dual core 2 CPUs on the server, but still, it's all the devices are sharing the same CPUs. So it's not like we'd be able to really test that out. So to rectify that, I am going to, and we're a rapid spanning tree here, I'm going to go to switch 2, and I'm going to go and type in here spanning, big T, spanning tree mode rapid, and do show span. So once it figures itself out, we should start to see a peer STP, which we do, which is what I want to see. So I know gig 2 and gig 3 on switch 2, gig 2, switch 3, gig 3 goes to switch 4. So I know that's exactly what I want, peer STP. So that means that the other switches are running regular spanning tree. Okay. Now I'm going to go over here to switch 3 and show spanning tree. We can see we don't see any of that STP parentheses because it doesn't know that it's not running spanning tree. So we're going to type in spanning tree VLAN, and I'm going to do a blanket statement 1 through 4096, and we're going to type in spanning tree mode rapid. and do the same thing for switch 4. And then we're going to go back to switch 1, hit the up arrow, and now we see that that share peer STP goes away. Even though our timers don't change, or the timers stay the same. So if we do show run pipe section span, we can see we change the hello forwarding time and max age for VLAN 1315. Okay, so that's how that would come into play. Good deal there. All right, so now that we've taken a look at that value, so we've taken a look at rapid spanning tree. There's really not a whole lot else going on here. Let's take a look at multiple spanning tree. So on switch 1, I'm going to type in spanning tree mode is going to be MST, and I hit the enter key. Now I'm going to do the same thing across the board, and you'll notice that we're going to get some interesting pop-ups coming in here now that we've gotten this applied. So what we're seeing here, scoot this over so then fully populate it out. So we're seeing blocking designated port gig 0/2 inconsistent superior PBST BPD received on 1315 claiming root. So it's basically just like, well, you know, I don't know what's going on here, so I'm going to block. So now that we're consistent again, if I do show span, we're going to have a different output. So you'll notice that the first thing to keep in the back of your mind is the port roles stay the same. It's MSTP, and the cost went up dramatically. So instead of being at 4, we're now at 20,000. So if we now they're full forwarding, which is in good shape, I'll come in here and do show span. Yeah, but you notice MST0, you're like, okay, well, where's the rest of the VLANs? Well, the reason why we have that, MST0 is the first instance of multiple spanning tree we've got. So now we have these other VLANs that we need to create an instance to. So right now we don't have any others. So we have to type in spanning tree MST, and then we need to create an instance range. So we're going to create, I'm going to say range in this particular capability. We're going to give it the instance. We'll type in configuration, and then you can create all of your configuration pieces. So we're going to say instance, and we're going to say 1 VLAN, and then what VLANs do we want to map. So I'll do 2. I'll do 1315 and 1316. So 1315 through 1316. And then I'll type in instance 2 will be 1318 through 1319. Okay. Now we can name this. Name. And then we can even put in here a revision number, and I'll give it a revision number 1. So if I do show span, you're going to see more than one instance. We're going to have instance 1, which is going to be running some other VLANs, and instance 2. But if you still notice that there's no VLAN showing up underneath it, right? The instances are kind of weird in how they're put together. So this root is the bridge, or this bridge is the root for this capability. So if you notice that no VLAN is showing up, if I did the same thing here, if I do show span, like I'm getting MST instance 0. I need to configure the same thing across the board. So do show run section span. I need to go ahead and create this guy everywhere. Okay. Now that I have that, if I go back to switch 2 and I type in do show span, so you can see it's a shared boundary RSTP, Now we're going to start to see how it's going to start figuring itself out. Why is that not triggering? Oh, you know what? That's right. I have to exit out of spanning tree for it to trigger. That's right. I forgot about that. So you can't be in configuration mode. You have to exit out of MST in order for it to take effect. So do show span. We're going to see these other guys squared away, and it's going to look identical, right? It's going to be difficult to pick it apart. And if we wanted to, we'd have to jump out of here and do a show spanning tree MST detail, and it's going to tell us who the root forwarding is and all that type of stuff. It'll give us some indication as to who's doing what and all that type of stuff. We also need to do configuration, and we can see which VLANs are mapped to which. Because right now, if we were to dig into it, we have to understand that if we do a show spanning tree MST service instance, okay, it's that might be a different output, but we get MST configuration. It tells us which one it is. So you'd have to know which VLANs are mapped to which specific instance in order to be able to do a show span and then see what it's talking about. So if I wanted to change the root bridge on a particular capability, right now I'm on switch 4. Let's say I wanted show span, and I should be the root for everybody, which I am. So let's say, for example, for MST2, I want to change the root bridge. So here I'd have to come in here and type in spanning tree and say MST. Is it configuration? No, it's two instance range. That's the range. Configuration MST 1, and then okay, there we go. It's MST 2. I want to say root is going to be primary. So now we go over here to switch 1. Right now this is the root, but I want to switch to the root for show spanning tree MST 2. Now the root port is gig, so it'd be easier just to show you show spanning tree. Go to the bottom here, and now the root bridge is going to be gig 0/1. So the root is now switch 2. So, and because we changed that MST2 for primary. So this is where it gets complicated when you're dealing with multiple spanning tree, because the fact that you're not able to look at it on a per VLAN basis, you have to look at it at an instance level, and then from there you need to know which VLANs are mapped to that instance, and then you're dealing with a single BPDU, not a bunch of BPDUs. That's really the optimization here. It's still using rapid spanning tree underneath the hood, but this is where the really cool capabilities come into play with how this logic works. I've never had any customers run this. I've made mention it to a customer, the one that I've talked about a few times now, that had a very large layer 2 environment, and they were trying to use campus networking to do data center networking, which doesn't work. So I made mention it to them, and it backfired, but because it had so many VLANs, and MST needs to have an instance there needs to be enough spanning tree available for it to work, and there just wasn't. The switches didn't have the horsepower to do the job. So that was the case. So in situations like that, it is it gets interesting. So just keep that in the back of your mind that if you want to manipulate how the network is doing its job, you need to understand how the process works first. And that's where I would have you come back here to understanding how MST works. And let's see. There are, maybe it's underneath this one. No. The spanning tree modes and protocols. So you have this one. MST is multiple VLANs the same as spanning tree instance. If you want to get into the specifics, you can. So just be aware of those things. So the last thing I want to talk about is going to be the first one was loop guard. So let me do them in order. Root guard comes before a loop guard. Actually, I'll take that back. So port fast. We've already seen port fast. Port fast comes into play. There's let me show you globally how this would look. Let me come back over to the topology though. So you would do this on switch 3 and switch 4. You would, and actually I want to show you on switch 6 because it's already configured. So show run interface gig 0/2. I have the spanning tree port fast edge, which basically means the interface is going to bypass listening and learning and go directly to forwarding and get the job done that way. So makes it much easier to work with in that regard. That's what port fast does. So the interface, as soon as it detects link activity, it's automatically going to go to forwarding mode so the end user can get on the network right away. So there's that. The next one is going to be BPDU guard. And over here on this guy here, we got BPDU guard. So BPDU guard, is it not going to BPDU guard? Okay, so port fast transitions interface directly to that. BPDU guard, you can either enable globally or on a per port, but when you enable the BPDU guard at the global level on a port fast edge, spanning tree shuts down ports that are in port fast edge operational state if any BPDUs is received on them. In a valid configuration, port fast edge enabled ports do not receive BPDUs. Receiving a BPDU on a port fast edge enabled port means an invalid configuration, such as the connection of an unauthorized device, and the BPDU guard feature puts the port into error disabled state. When this happens, the switch shuts down the entire port on which the violation occurred. So if, for example, what I'm going to go do is, I'm not sure if this is going to work globally on this switch or not, but I'm going to do this on switch 3. I'm going to type in the command spanning tree, and it's going to be port fast edge default, or it's going to be BPDU guard default. What this means is any interfaces that have the command port fast configured on them, by default, are also going to inherit BPDU guard. So what I'm going to do is I'm going to type in interface range gig 0/2 through 3, and I'm going to type in spanning. I'm going to say switch port mode of access, and then it's going to be switch port access VLAN 1315, and then spanning tree port fast, and then edge. Okay, so that's going to be what we do there. So what will end up happening is, so if I do a show spanning tree, it's going to be interface gig 0/2 port fast edge. It's enabled for MST0 and MST1. Let me go ahead and scoot this guy over a little bit. And what I'm going to do is I'm going to enable PC39. PC39 is actually a switch. And that guy's going to come online. I'm going to click on him. And so switch 3, momentarily, we should see it squawk. When it comes online. And there it goes. it says, okay, receive BPDU on port gig 0/2 with BPDU guard enabled, disabling port. BPDU guard error detected, gig 0/2, putting gig 0/2 in error disabled state. Line protocol for interface gig 0/2 is changed to down. So because of the fact that it detected a switch on its interface, so it got a BPDU in. The BPDU came in, and therefore with BPDU guard enabled, it took the port down. So what I'm going to do is I'm going to say that this command that we typed in here a couple moments ago, this command right here, I'm going to pull this one out. I'm going to pull the command no out, and then I'm going to go to the end. I'm going to say, instead of BPDU guard, I'm going to put in BPDU filter. Okay, so now if I do this command again, gig 0/3, because I'm about to turn on PC40, we can see it is enabled on that interface. So if I come over here to PC39, PC39 is none the wiser. You can see it says switch, and we'll fix that here momentarily. So what I'm going to go do is back to here. It's PC40, BPDU filter. If we look at back on this guy, BPDU filter says that BPDU filtering can be enabled globally. Says enabling BPDU filtering on port-fast edge enabled interfaces at the global level keeps those interfaces that are in port-fast edge operational state from sending or receiving BPDUs. The interfaces will still send a few BPDUs at link up before the switch begins to filter outbound BPDUs. You should globally enable this filtering on a switch that hosts connected to these interfaces do not receive BPDUs. If a BPDU is received on a port-fast enabled interface, the interface loses its port-fast edge operational status, and BPDU filtering is disabled. So it doesn't take the interface down. So it says enabling BPDU filter on an interface without also enabling port-fast keeps the interface from sending or receiving BPDUs. So I'm going to go back to here, and I'm going to start this guy so you guys can see what BPDU filter does. So switch 3 should have another squawk here. Oh, I didn't. PC40. So doesn't seem like anything's happening. Switch 2, timing out. Switch 4, timing out. Switch 3, not a lot. BPDU guard is obviously much more involved because of the fact that it actually takes it errors out. If we did a show interface status, we would see that gig 0/2 is error disabled. Now there is a way to recover this, and I'll talk about that here in just a minute. If we were to bring this over here and scroll up, we have the error disable recovery. I'm going to talk about that here in just a minute. Okay, so at this point in time, PC40 is online, but switch 3 hasn't seen anything. If I hit the up arrow, right, nothing's going on. Now what I'm going to do is on PC40, and PC39, what I'm going to do is I'm going to come up here. The host name is going to be PC39. Say no IP routing. I'm going to say that interface gig 0/0. I'm going to say is no switch port. So I'm going to make it a layer 3 interface and not a trunk. So now that that's done, I'm going to go over to, and I'm just going to say that config for right now because I don't want to do any more to it than I already have. What I'm going to do is on switch 3, I'm going to go to global config, and there's a manual way of recovering an interface, which is going to the interface and typing shut, no shut. So I'm not going to do that though. I'm going to type in error disable detect cause and you can see there's a whole bunch of options here, right? We have spanning tree, SFP config mismatch, ARP inspection, DHCP, all, loopback, all that good stuff. But if I come in here and type in recovery cause, and I type in, for example, BPDU guard, right? BPDU guard, and then I say the recovery interval, error disable recovery time or value, and I say is going to be, say, 30 seconds. So what I want to do is every 30 seconds that there's an interface in error disable mode, I want it to try to automatically recover it. So if I jump out of here and I do a show error disable recovery, we are enabled, and time left. Interfaces that will be enabled at the next timeout will be, it didn't take the configuration I wanted it to. So show run section error. Yeah, it's going to take a little longer than I expected it to. So it's going to do that. So what I'm going to do is I will pause for that time frame. It'll wait, so it's basically waiting 5 minutes, even though I wanted it. It might actually, interfaces will be enabled at the next timeout. So it might do it before that. Let me scroll up here just a little bit so we can get the output in one shot. And we do a show interface status. Right now we're still error disabled on gig 0/2. So we have 200 seconds left. So I'm just going to go ahead and just pause until that time's out, and then I'll bring you guys back in. Alright, so as you can see, the line protocol was able to recover, and if we do a show interface status, we can see that the interface is now connected. So that is how error disable recovery would work in this particular case, so you guys can see how that operationally comes into play and all that good stuff that goes along with it. So you can do a bunch of different recovery options. You can do a detect on a bunch of different stuff as well. So we'll take a look at some of these other options as we go through. There is a bullet point here to do channel misconfiguration guard. We'll do that as well, where we have like an issue like LECP versus PAGP. We're going to do something like that, where there might be a interface level config, speed or duplexes mismatch, and it'll shut down the port channel, things like that. So with that being said, the last thing that I wanted to talk to you guys about is loop guard and root guard. So let me scroll to the top here and talk a little bit about, we'll go root guard first. And root guard, it applies to on interfaces enabled on interface applies. Root guard enabled on an interface applies to all VLANs to which the interface belongs. Do not enable the root guard on interfaces used by uplink fast feature. With uplink fast, the backup interfaces in the block state replace the root port in the case of failure. However, if the root guard is also enabled, all backup interfaces used by the uplink fast feature are played in the root inconsistent state, blocked, and are prevented from reaching the forwarding state. So when you type in the command, enables root guard on the interface, so it prevents that interface from becoming the root port. Is what that does. And loop guard, you can use loop guard to prevent alternate or root ports from becoming designated ports because of failure that leads to unidirectional link. This feature is most effective when it is configured on an entire switch network. Loop guard operates only on interfaces that are considered point-to-point by the spanning tree. So what that means is you would do a specific interface to make sure that if there's a flip in the network, that it's point-to-point. And so one of the things you got to keep in the back of your mind too, if we pull up the CLI, you notice how if we do a show spanning tree, you see a lot of shared, right? This needs to be changed. So what we need to do is go to global config, and let me bring this down so you guys can see what I'm talking about and get out of the way. So on switch 3, go to interface gig 0/0, type in spanning tree, and you type in link type, is going to be point to point. And you do the same thing on switch 1, gig 0/2. So you would do interface gig 0/2 spanning tree link type is going to be point to point. Now when you do that, and we type in do show span, you're going to start to see that gig 0/2 is point to point now. You'd be able to turn on loop guard here. And just remember, you can't do loop guard and root guard at the same time. It's one or the other. So that is the case. So I would do loop guard over root guard, because there might be a chance where you might want to change the root situation. But loop guard is definitely if I was going to go one or the other, I would do loop guard. So that is pretty much that, ladies and gentlemen. So if you guys have any other questions, comments, concerns, please leave a comment in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all you fine people in the next video. Have a good one, everybody.